Hi guys, how are you today? So today I'll be explaining the physics or mechanics course practice of section 1.6 till 1.8. Let's start with the first question. The graph below shows how 3 runners completed a 100-meter race. Which runner won the race? Logically speaking, the person who finishes all the distance in the shortest amount of time is the winner of the race. In this case, the shortest amount of time belongs to Albert, which is 12 seconds. So that means Albert won the race. Now, which runner stopped for a rest? How do you know which runner stopped for a rest? Very simply, you will look back at the graphs and you will see which runner stayed at the same position for a certain amount of period. So as you can see over here, they're all increasing except for Charlie. So Charlie's increasing, then it remains flat. This means what? It stayed at the same position for a certain amount of time, and then he continued again, so it's increasing again. This literally only means what? This position over here, or this part of the graph, means that he took a rest or he stopped moving. So he took a rest or stopped moving. So definitely the person who stopped for a rest was Charlie. So we move on to question number 2. What does it say in question number 2? It says the xt or position time graph shown below represents the motion of a particle moving along a horizontal axis. They told us the moment of time when the particle is instantaneously at rest. My bad. What does it mean instantaneously at rest? Very simply, we're dealing with what? We're dealing with a position time graph. So when it is instantaneously at rest, that means our slope should be 0. Why should our slope be 0? Because if our slope is 0, that means he's staying at the same position for long time. So he's staying at the same position for a long time. This means he's not moving. That means he is at rest. So very simply, looking back at the graph, the only time when the slope is 0, or where it looks like he's coming to rest, is at which time? Is at 5 seconds. Okay, so this one is 5 seconds. We move on to part B. It says in part B, at time 11 seconds, let me just fix my tablet. At time 11 seconds, the approximate instantaneous velocity of the particle. They want us to find the instantaneous velocity of the particle. How do we find the instantaneous velocity of the particle? Very simply, what we're going to do is we're going to find the slope of the tangent. So first thing we need to do is we need to draw a tangent, since there's no tangent drawn for us, okay? And then we need to find the slope of the tangent, and we would have found the instantaneous velocity. So let's go up, okay? Let us try our best to draw a good tangent. So we could do it like this. So this is a good tangent. Actually, it's not too good. Let me make it a bit better. Okay, this is gonna take some time to draw. Let me zoom in so it will be a bit easier. Okay. You will struggle with me a bit. You will wait for me to draw this in a good way. Okay, this works. This works as a tangent. Just consider this as a tangent, okay? I'm not the best at drawing. Usually they are supposed to give you the drawing. If not, then you will just have to try and imagine a tangent. Okay, and we will need to find the slope of the tangent. So let's find the slope of the tangent together. Take 2 points. For example, this point over here, it's a good point. What's this point? It is 9, 12. And then this point over here as well is a good point. What is this point? This point is 13 minus 12. Now let us find the slope of the tangent. You can do, for example, y minus y over x minus x. So minus 12 over 13 minus 9. So you only get minus 24 over 4, so minus 6. And just like that, we found the instantaneous velocity. It is minus 6 meters per second. Now at 11 seconds, the approximate instantaneous speed. We stop for a second. We found instantaneous velocity, but they want what? They want the instantaneous speed. The relation you need to know between instantaneous speed and instantaneous velocity is that instantaneous speed is equal to the absolute value of the instantaneous velocity, okay? If it is at the same time, of course. So in this case, we have the instantaneous velocity, which is -6. It will be equal to what? The absolute value of -6, which is what? Which is 6. So very simply, the instantaneous speed is the same as the instantaneous velocity, but in absolute value. So in this case, it's gonna be 6 meters per second. We move on to question number 3. In the first leg of motion, a bicycle accelerates from rest in the positive direction at 1.5 meters per second squared for 6 seconds. In the second leg of motion, the bicycle decelerates to full stop in 5 seconds. So look how this works. We have 2 legs of motion. First leg of motion, bicycle accelerates from rest. So let's say rest is here. It accelerates at 1.5 meters per second squared. So this is the slope for 6 seconds. So the time taken was 6 seconds. Then in the second leg of motion, he decelerates. So he's going down and to a full stop in how many seconds? In 5 seconds. So it took in total 5 seconds, but the total time is 11 seconds because it's 6 plus 5 seconds. Now, what we need to know is because the same distance is, not the same distance, sorry, the same velocity is used, okay? How do we know? Because it started from rest, it went to a specific velocity, and then it went back to rest. That means what? It's gonna be the same velocity being used or a constant velocity. So very simply, if you find the velocity of the green part, then it's going to be the same as the velocity of the red part, and this will help us to find what the magnitude of the deceleration of the bicycle. So let us first find the velocity of the green part. It's very simply acceleration times time, so 1.5 times 6, which is 9 meters per second. Now that we have the velocity, we can use it to find the acceleration. So we have the time, which is 5 seconds. So acceleration is equal to velocity over time. So it is 9 over 5, which is what? Which is 1.8 meters per second squared. But because it's because it's decelerating, okay, so it's going to have a negative sign. But pay attention to the question, they want the magnitude. So you're going to put it in absolute value to get what? 1.8 meters per second squared. So this is 1.8 meters per second squared. Now here, very simply, look how I do this. You can either have speeds up, positive direction, you will multiply them, you will get positive acceleration. Or you have slow down in a positive direction, okay, and you will get what? A negative acceleration. Or you could have what? You could have speeds up, but in a negative direction, so it's gonna be what? It's gonna be a negative acceleration. Or you have slows down in a negative direction, then you will have a positive acceleration. So speeds up, positive, it's gonna be positive. Slows down, this is minus, my bad. Positive, it's gonna be negative. Speeds up, negative, it's gonna be negative. Slows down, negative, it's gonna be positive. So plus times plus is plus, minus times plus is minus, minus times minus is plus, and plus times minus is minus. Okay, so here definitely it is gonna be greater than 0 or positive. This is gonna be negative, negative, and then positive. We move on to question number 4. The velocity time graph below summarizes the motion of 2 cars, A and B. So, which car is moving faster at the start of the motion? So, what do we mean by it's moving faster? Very simply, it means that it will cover the same distance but in a shorter time. I believe that car A and car B, we can see that they have almost the same distance. So if they traveled the same distance, that means for sure car A was faster. Why? Because it finished in a faster time, or like not a faster time, in a smaller time. So definitely car A is moving faster. But which car ends up farther from its starting point? So look, car B did not finish. So for it to finish, it will still need to, It will still need to move and continue. And this will take what? This will take more time. That means more distance is moved as well. That means car B will be what? Will be farther away from its starting point. Now finally, which car experiences a greater magnitude of acceleration? For sure, the one with the steeper slope, which in this case is car A. Definitely always the one with the steeper slope is what? It is the one with the greater magnitude of acceleration. We move on to question number 5. So we have part A, the acceleration of the elevator at time 2 seconds. Very simply, you will go here, you will find the time, this is the time for sure, and you will say what is the acceleration at this time. So at time 2 seconds, the acceleration, remember this is what, an acceleration time graph. So this is the acceleration, right? So the acceleration at time 2 seconds, it is what? It is 4 meters per second squared. So it's going to be 4 meters per second squared. Now the instantaneous velocity of the elevator at time 4 seconds. So how do we find the instantaneous velocity? First of all, at 4 seconds, if you go up, you will see that it has an acceleration of 4 meters per second squared. But we also have the time, which is 4 seconds. So how will we be able to find the instantaneous velocity? Very simply, it's going to be what? It's going to be velocity is equal to acceleration times time. So it's the acceleration, which is 4, times the time, which is what? Which is also 4. So 4 times 4, it's going to be what? 16 meters per second. Right? We move on to the next part. They want the displacement of the elevator at time 4 seconds. So let us go at the time 4 seconds, okay? At the time 4 seconds, what is the acceleration? The acceleration is 4 meters per second squared. But however, they wanted to find the displacement. So this, we should use an equation that I think you guys should have memorized. Very simply, this equation is what? This equation is delta x, or displacement, is equal to velocity initial times the time plus acceleration, plus 1 over 2 times the acceleration times what? Times the time squared. Right? Now here's the thing. Time, okay? This time over here is what? This time is time initial. So what is the time initial? Time initial in this case is gonna be 0. So delta x is equal to what? V initial times 0 plus 1 over 2 times what? The acceleration, we have the acceleration, which is 4, times the time, this time we're talking about, not the time initial, which is 4 squared. So there's no need for us to find the velocity, even though I believe the velocity was 16 because we found it previously, 16 meters per second. So even if you put 16, it's still gonna be 16 times 0, which is 0. So delta x is equal to 0 plus 1 over 2 times 4 squared, which is 32. So very simply, delta x, or displacement, is equal to 32 meters. So very simply, the displacement of the elevator at time 4 seconds is 32 meters. We move on to the next part, which is the acceleration of the elevator at time 10 seconds. Very simply, what we're going to do is we're going to go to the time 10 seconds. We're going to draw a line. Where's the acceleration? It is at -4. So the acceleration of the elevator at time 10 seconds is -4 meters per second squared. We move on to the next part, the instantaneous velocity of the elevator after 12 seconds. How do we find the instantaneous velocity of the elevator after 12 seconds? Very simply, you will just find where it is over here. Now notice here there is a difference. They want the instantaneous velocity of the elevator after 12 seconds, whereas here they wanted it at time 4 seconds. Here they want it after 12 seconds. So what's the difference? At time 4 seconds, you're going to take the one from the previous graph. So this is at time 4 seconds. But they're asking for time 12 seconds. So if you draw this, you're going to have this. But do they want at 12 seconds or they want after 12 seconds? No, they want it after 12 seconds. So you're going to ignore this completely and you're going to take what's after 12 seconds. You see acceleration is equal to 0. You have the time, which is, I don't know, let's say it is 12, for example. So velocity is equal to acceleration times time. So 0 times 12, which is what? Which is 0. So very simply, it is going to be 0 meter per second. Now they said, select the velocity time graph that correctly represents the motion of the elevator during 12 seconds. So we are given what? The acceleration time graph. We have two parts, the positive part and the negative part. Okay? So they said they want it until 12 seconds. So we will stop at 12 seconds. First, you will see that it is what? It is accelerating uniformly, because as you can see, it's a straight line. So it's accelerating uniformly. And then it goes to what? It goes to 0 acceleration or constant velocity. So at first it had an acceleration, which is 4 meters per second squared. It was accelerating uniformly. Then it became what? It became a constant velocity. Then after becoming a constant velocity, its acceleration is negative. So it's not accelerating, it's decelerating. Decelerating uniformly. All right. And then it goes back to 12, which is the final point. So basically, you have to look for something that's first accelerating uniformly. Okay. So for sure, it's not this or this because these are decelerating. So we're left with this option or this option. But if you go up here, you will see that it starts from the origin. Well, technically, it's supposed to start from the origin, right? Because what did they say? They said initially at rest. So if it was initially at rest, that means its velocity was supposed to be starting at 0. But if you go up, we need to remember what was the highest possible velocity we calculated. Highest possible velocity is over here. Okay, this, if you remember, we calculated over here, which is the instantaneous velocity at time 4 seconds, which is 16 meters per second. So you have to go back and you have to find the one that is 16 meters per second. That's obvious, it's 16 meters per second. So definitely I would choose this one over here. It looks more like it. Oh, but even further, we know that it's decelerating at -4. So it was accelerating at 4, decelerating at -4. That means acceleration and deceleration are gonna be the same slope. Okay, same slope, but opposite direction, very simply. So now we move on to question number 6. What does it say? It says the velocity time graph below describes the motion of a particle. A tangent to the graph at point time 5 seconds is shown by a dashed line. This is a case where they drew for us the tangent. This tangent passes through 1 second 7 meters per second and 12 seconds 0 meters per second. They told us the particle is instantaneously at rest. How can the particle be instantaneously at rest? This is if the velocity, velocity is equal to 0. So we have to look for 2 points or more where the velocity is equal to 0. Velocity is equal to 0, we will find it here at the origin. So we have this point over here and this point over here, which is what? Which is 8 seconds and 13 seconds. So very simply, it is 8 and 13 seconds. Now, the instantaneous acceleration of the particle at time 5 seconds to 1 decimal place. So how do we find the instantaneous acceleration? Remember, we're dealing with instantaneous and not average. So to deal with the instantaneous acceleration, we will need to find the slope of the tangent. Right, so we can select 2 points. Let us select 2 points together. For example, the points that they gave us already, these 2 points, okay, we will use them. We'll do y minus y over x minus x. So it's gonna be 7 minus 0 over 1 minus 12. Put it on the calculator and you're supposed to get minus 0.6 meter per second squared as your answer. All right, we'll move on to question number 7. They said consider the position time graph of a descending drone. They want to know the magnitude. Remember, when they want magnitude, you will take it in the absolute value. So how do we do this? First, we will find the slope. Why? Because it's a distance time graph and we need to find the velocity. So we will find the slope and then we will put it in absolute value. Right? So choose any 2 points of the slope. We can choose this point over here and this point over here. So it's going to be 20 minus 5 over 0 minus 6. Put it on your calculator. And you're supposed to get an answer which is minus 2.5. However, since they want the magnitude, we will put it in absolute value. And then it will become what? It will become 2.5 meters per second. We'll move on to question number 8. They said a car initially moving at 30 meters per second decelerates to 5 meters per second in 3.8 seconds. They want the acceleration of the car. So 5 meters per second, subtract it. We have velocity initial, velocity final, and we have the time. In order to find the acceleration, we know that it's the change in velocity over time. So v final 5 minus v initial 30. You're going to subtract them over the time, 3.8. You will put it on your calculator and you will get minus 6.6 meter per second squared. Okay, we'll move on to question number 9. So here we're given what? A velocity time graph, and we'll need to find the magnitude. Remember, whenever you see magnitude, you will put it an absolute value. The magnitude of the car's acceleration. Okay, So they want it at what time? At time 1 second. Look, because we're dealing with a slope, okay, and we're dealing with what? An acceleration, not instantaneous acceleration, but acceleration in general, then we will find the slope of the line, okay, because it's a straight line, then we're definitely gonna use it. Alright, so let's find the slope of the graph. For example, choose 2 points. I will choose this one and this one just to make my life easier. So this is point what? 0, 3 and 1, 1. So we will use x minus, y minus y over x minus x. Okay? So in this case, it's gonna be what? It's gonna be 3 minus 1 over 0 minus 1. You will get an answer of minus 2. But since they want the magnitude, you will put it in absolute value to get an answer of what? An answer of 2 meters per second squared. We'll move on to question number 10. They said the diagram below shows the variation of a car's velocity with time and the tangent to the curve. Okay, here they were nice and they gave us the tangent, right? So what we're going to do is we're going to find the instantaneous acceleration. Remember, instantaneous acceleration. In order to find it, we will need to find the slope of the tangent. So let's take any 2 points. For example, this point over here, which is 40, 15. And this point over here, which is what? Which is 10, 5. We will do y minus y over x minus x. So 15 minus 5 over 40 minus 10. Minus 10. You will get an answer of what? Of 0.33 meters per second squared. So very simply, it is 0.33 meter per second squared. Let's submit and hopefully we don't have any mistakes. Perfect, thank God we don't have any mistakes. Thank you guys for watching. I hope you enjoyed and have a wonderful day.